All right, it's me, Dr. Townsend, once again. And this lecture, we are going to talk about one of my favorite topics, actually, which is the moon. So I'm an astronomer, right? I'm not supposed to like the moon. If your goal is to view things that are very faint, which is what a lot of astronomers really strive for, the full moon is kind of your enemy, right? The full moon, if you're ever out when it's full, it's the brightest thing in the night sky, and it really lights up everything, and that overwhelms a lot of the other light, of the other stars. But I actually really like the moon, right? It's so big and bright. It's almost tangible. How many other worlds can you just go outside and look at its surface, right? This is very rare. And if you've ever looked at a moon through a telescope, you can really see the contours of its cliffs and its craters. It's the only place in the universe other than the Earth that human beings have been. So I love the moon. I feel like I could talk about it for hours, but I do understand this is a class, you have limited time. I will try to limit myself to some of the basics about moon phases and what that tells us about the moon's orbit around the Earth. So the title slide showed an image of the moon during several of its phases, right? This was the slide here. We're looking at the different phases of the moon. So it starts out as invisible new moon phase, and it starts to wax, which means it starts to get bigger. It reaches its full moon phase, and then it goes into its waning phases. It gets smaller until it becomes a new moon again. But I want you to take just a second to consider what the major cause of these phases is that we see. So, is it the relative angle of the sun, the earth, and the moon? Does the earth cast a shadow on the moon each month? Or do moon phases appear just randomly each night? So maybe pause the video here, take a couple of minutes or, 30 seconds or so to think about what the answer to this question might be. Okay. When we talk about phases of the moon, we're talking about the part of the moon that is illuminated that we can see. So sometimes it's a sliver and sometimes it's more. The moon doesn't make its own light. It's not a star, but instead it reflects the light from the sun. I think it reflects only about 10% of the sun's light, but even so, the full moon is extremely bright. So the moon is always half illuminated by the sun, just the same as Earth. So the phases we see have everything to do with where the moon is in its orbit around the Earth. So that is what this illustration is trying to show. So down here in this dark blue band is what the moon looks like from Earth, and here is where that moon is in orbit around the sun. So we can see at the new moon phase, we can't see the moon at all. It is pretty much directly between Earth and the sun. Like the illuminated part of the moon, we cannot see at all. As the moon kind of travels around, we start to see more of that illuminated part until we get to a full moon here where the sun is actually illuminating that full side that we can see of the moon. And then as it goes along its orbit again, it becomes smaller and smaller until we get back to the new moon phase. The cycle of moon phases takes about 29 and a half days. So we start the cycle with the new moon, so the moon that we cannot see. The moon goes through its waxing crescent phases. You can see the crescent that we can see gets bigger and bigger each night. Waxing just means it's getting larger, so we see larger and larger slivers of the moon. After about 7 days, the moon hits its first quarter, right? We see a quarter of the surface being illuminated, but remember, the moon is always half illuminated. It's just what we can see from Earth. After the first quarter, we go through a waxing gibbous phase, which takes about 8 days until we finally get to a full moon. As you can see, the moon looks pretty full in the days before, but not officially full until about 8 days later. Then the moon goes into its waning gibbous phases, so it starts to get smaller and smaller and smaller until it reaches its third quarter. So you can tell the difference between first and third quarter because the third quarter, the left side of the moon is illuminated. The first quarter, the right side is illuminated. Okay, so we're at third quarter. The moon enters its waning crescent phases. So we start getting a smaller and smaller little crescent shape until ultimately we are back up here at the new moon and the cycle starts all over again. So it is possible that you haven't noticed some of these phases because of when the moon rises and sets. Every day throughout the lunar cycle, the moon will rise about an hour later than it did the day before. For example, during the new moon, the moon appears very close to the sun in the sky. So this image up here represents the moon at its new moon phase. So it rises at sunrise with the sun. The next day it will rise an hour later, and if we're paying attention, we might be able to see a very thin crescent. This goes on and on until the full moon phase, when the moon is on the opposite side of the sky as the sun. So the moon rises at sunset. That's what this image down here is meant to represent. At sunset, this full moon starts to rise. From then on, the moon will continue to rise an hour later each day until we're back at the invisible new moon phase. There is a link to a short video in this module that really illustrates this beautifully, and I do recommend that you take some time and you actually view that video. Even if you normally miss some of these phases, you've likely noticed that you only really ever see one side of the moon. One side of the moon is always facing Earth, and this is called synchronous tidal locking. It's extremely common in the solar system. All large moons in the solar system are tidally locked to their planet. So if the moon were not tidally locked, we'd be able to see more of the moon as it orbits Earth. So we have this little illustration here. Let's see if it will work, of what happens. So right here we have a moon that is tidally locked. And it is orbiting about the same time as it rotates. So the moon is still rotating on its axis at the same rate that it's going around the Earth. So we only see this smiley face. If it was not tidally locked, we would see something like this. The smiley face doesn't always face the Earth, and so we would see pretty much the entire moon as it went around the Earth. But that's not what we see, right? We have a moon that's actually tidally locked. So we know that we're only seeing one side of the moon because we have sent spaceships to the other side of the moon. And the pictures they've sent back show actually a very different landscape. So this is an image here taken by the Lunar Reconnaissance Orbiter in 2011. And this is an image of the near side of the moon, right? The side that we see. So you can see the near side of the moon. You have these dark patches here. These are basically plains on this side of the moon. And over here, there's just a lot more craters just all over the place. It's definitely a different type of landscape. Sometimes the far side of the moon is called the quote unquote dark side of the moon, but this is really, it's a misnomer. Remember, the sun always illuminates half the moon. So this side gets as much daylight as the near side that we always see. Let's just really quickly revisit this question of how we get moon phases, right? The answer is A. we get phases due to the relative positions of the sun, earth, and moon. So I suggest you go and you play around with the moon phase simulations in this module and watch the additional videos. And after you do that, you can move on to the lecture about eclipses, which is a very related topic.